So here quickly we just want to go through quasi-experimental designs and the different types that we discussed during class and that are fair game for the final exam. The first type of quasi-experimental design, actually, before we go into that, let's just go down to this definition here. A true experiment uses manipulation and control. A quasi-experiment is different in that it uses no randomization. If there's no randomization, it is a quasi-experiment. If there is randomization, it's a true experiment. Both use manipulation and control, may use manipulation and control. Quasi doesn't necessarily have to have a control, but it can. A true experiment tries to establish internal validity, so it wants to establish causality, whereas a quasi-experiment is more concerned with establishing external validity, as we mentioned here, and that we'll go into a bit later. Now, there are a couple of different types. What you should focus on when understanding the different types is how many measurements are taken before and after intervention, and is there a non-equivalent control group. What a non-equivalent control group is a group that isn't quite the same as the sample, but it's similar enough that we can use it as a control to control for confounds such as history effects or other confounds, like we spoke about in the last activity during class. If we're measuring, if we're using Texas as a sample, we might use another large, mainly Republican state, similar belief, similar size, similar socioeconomic conditions, as similar as possible. We'll use another state as a non-equivalent control. Now, in the one group, pre-test, post-test, quasi-experimental design, we're using one experimental group. We're measuring once, having an intervention, and then measuring again to see if there's a difference. This method is crap. It involves no control. No definitive conclusions can be drawn from such a study because there's no control, and all threats to internal validity may be present here, which we'll speak about separately. And if you look at this little representation I have down here in italics, one measurement, one intervention, one measurement again. That's all. No control group, no baseline over time, no measurements over time, nothing. Not very good. Let's improve upon that. Non-equivalent control group design introduces a non-equivalent control group, and it's the same in all other regards, but we add a similar control group. Non-equivalent, but similar. Now, we still don't have randomization, so it's still a quasi-experimental design, and it's still vulnerable to the additive effect of selection, which we'll speak about a bit later. Now, in the experimental group, we do measure, intervene, measure. Now, the non-equivalent group, we measure at the same times, but we don't introduce the intervention. That's what makes it the control. And that's all there is to it. If you understand the difference between those two, then you understand the difference between those two. There's nothing else to it. In the interrupted time series design, we get a little bit better. There's no control group, but it's better than pre-test, post-test because many observations are taken before and after the intervention. So if you look down here, we measure 4 times. We're establishing a pretty stable baseline. Then we have an intervention. Then we're measuring another 4 times to establish change from baseline. Now, this works well for time interventions where long-term effects are desired, but we still have instrumentation and history as threats to internal validity because there are no control groups. But maturation, testing, regression to the mean are all well controlled for by obtaining baselines over time. The requirements for an interrupted time series design are that we have a relatively stable baseline and an abrupt discontinuity or intervention in the time series, which is represented by the X in the graphical representation that I have here. Now we can make this better. Again, we can add a non-equivalent control group, and then our design would be called a time series design with non-equivalent control group. Similar to interrupted time series designs, we have a baseline before, an intervention, and a baseline after. not a baseline, so to speak, but a measurement over time to see how the baseline has changed. But we add a non-equivalent control group, similar to how we added a control group to the non-equivalent control group design to delineate between these two. We add a control group to delineate between these two modes as well. We want the control group to be as similar to the sample group as possible, even though it's non-equivalent. And this technique rules out history and instrumentation effects because of the control group. If you look at the graphic, we can see the difference very clearly. We still have 4 measurements before, 4 measurements after, and it's not necessarily 4, it could be any number in the general case. The only difference is that no intervention in the case of the control group. Hopefully now you can describe the different types of quasi-experimental designs that we might encounter on the final exam, and delineate between a true experiment which uses randomization and a quasi-experiment which does not use randomization.